The chapter has to do with inverse functions. It's called as inverse trigonometric function, the chapter heading. So it has to do with something called as inverse functions. But what is inverse function? Our inverse function is a function that reverses the input-output mapping of the original function. This is one of the most simplest way of putting it across. So let me explain this way. So we're looking at a function which has a domain of 3, 5, 8, 41 and the codomain is 3, 9, 18 and 17, 117. Don't look into the logic. I don't think I have put any logic over there. So the function will map 3 to 3, 5 to 9, 8 to 18, 41 to 117. Right? Now, the inverse of this, the inverse of f of x, which is denoted by, in that manner, f inverse of x, will flip the domain and codomain. The domain of the inverse function will be the codomain of the actual function. And the domain of the, or codomain of the inverse function will be the domain of the actual function. So things will be flipped. And the mapping will also be flipped. So 3 will be mapped to 3, 9 will be mapped to 5, okay, 18 will be mapped to 8. So you need to understand where the lines are starting from. Here the lines started from, as you guys can see, the lines are starting from the domain, right? 3, 5, 8, 14. And over here, the lines are starting from 3, 9, 18 and 117. So this is the role of our inverse function. It will flip things around. But yeah, numbers which are mapped, they will be mapped. 3 will be always mapped to 3. 5 will be always mapped to 9. This 2 will be linked and that is not going to change. Okay. So basically, we have a function and the inverse of that would be f inverse of x in this manner. Here, if I have a domain of say 1 and 2, here the domain would be, or let me put it across. Okay, let me do this. Here the codomain will be 1 and 2, right? And if the codomain over here is a and b, here the domain will be a and b. Okay, so I hope first you guys have to keep this in mind. Now, if I happen to map 1 to b, here b will map to 1. And if I happen to map 2 to a, here a will map to, yes, correct, 2. So that's what our inverse function do. One thing we have to keep in mind is not all the functions are inverse functions or can have inverse function. So what is the condition? A function to have an inverse function needs to be a bijective. If you guys remember, it is nothing but a function that is 1, 1 and on 2. That is, it needs to have every element at the output to be mapped to exactly one element at the input. So the pre-image has to be only 1 for every image. And every element in the codomain has to be part of the range. That is, it needs to be part of the output. We need to define the sets and the function in this way. Only then it will be a function that can be inversed. But what's the point of this? Why should we call a function which is kind of opposite of a function? Why should we call it a name? Why can't we just give another name, Why should we call it as an inverse function, right? Where is it used? One of the usage is your encryptor and decryptor. Let me show this. Here, the encryptor has a domain that is called as plain text over here, has HELLO. Now, at the codomain, what are we looking at? At the codomain, we are looking at KHOOR. Here it's called as ciphertext, right? So let's see what it maps to what. So it's mapping H to K, E to H, L to O, and O to R. So this is your encryptor, a function called as encryptor. And decryptor is a function which is inverse of encryptor. So here the plain text becomes your KHOOR, while your ciphertext hypertext becomes HELLO. So basically what happened, if I happen to send on an app, say a messaging app, what happens if I type it on the internet, a word hello will go as KHOR. So anyone in the middle, they won't be able to guess it directly. While at the other end, a person who is getting the message will have the decryptor. He or she will not see KHOR being received, they'll see the word hello. But the decryptor will know what word has to be, what letter has to be mapped to what. And so, inverse function can be used in this manner. Of course, there are many usage. This is one of it. Now, if I happen to call this as an encryptor and say this is a decryptor, now say I'm sending a message, a number to a person, 1 and 2. Very important set of numbers that I have to send to a person. So I'll send it. The function f of x or the encryptor will change 1 to b and 2 to a. So the message will be sent as b comma a. Now, a person at the receiving end will have f inverse of x, a decryptor, that will map b to 1 and a to 2, right? So the person at this end will see the message as 1 and 2 itself. So by chance, if someone in the middle was trying to look into what you're sending, the person will not understand, right? Because it is encrypted. Say it's a password or something, the person will not get to guess it because they're looking for a number, but here set of letters are going. So the person in the middle will not understand. So this is a decent introduction or a good introduction to actually inverse function. So I would like you guys to understand all of this again. It's not that hard actually, and copy this. That's the main thing.